Welcome to Lesson 12-5, Permutations. Our Indiana Academic Standard is 7.4.5. Our vocabulary for this time, we have permutation, which is an arrangement of objects in a particular order. We also have factorial, that is the product of all positive integers less than or equal to a number. The symbol for a factorial is an exclamation point. If you see a number followed by an exclamation point, they're wanting you to find the factorial. We have an example here. We have 5 exclamation point. That means 5 factorial. To find that, you would take 5 times 4 times 3 times 2 times 1. We can do another one. This is 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If you need more time, pause the video to finish writing the definitions and these 2 factorial examples. Now we're going to find the permutations of the letters T, I, G, E, and R. The first letter can be any of the 5 letters. You have 4 choices for the second, 3 choices for the third, 2 choices for the fourth, and 1 choice for the 5th letter. So if we use the counting principle, we have 5 times 4 times 3 times 2 times 1, which gives us a total of 120 different combinations. So there are 120 different permutations. Pause the video at this time if you're not finished with this part of the lesson. Now we're going to find permutations using factorials. How many different ways can you arrange a nickel, a dime, a penny, and a quarter in a row? We have 4 ways to place the coin, so we do 4 factorial. So that would be 4 times 3 times 2 times 1, which gives us a total of 24. You can make 24 different arrangements of the coins. Now we'll do a different example. How many different ways can you arrange the 8 colors in a crayon box? Notice a typo there. Well, we do an 8 factorial, which would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320. I challenge you to find the different ways you can arrange 16 colors. The answer won't be on here, but let's see if you can tell me in class tomorrow. Pause the video if you need more time for these examples. Now we're going to a horse show. We're going to find the permutation for the red, blue, red, and green ribbons for 16 horses at a show. That means we're only giving out 3 ribbons, blue, red, and green. But we want to know how many different combinations there are of how many different horses can win. There are 16 possible horses that can win the blue ribbon. Once a horse wins a ribbon, they're not eligible for the other ribbons. After that, there are 15 horses that can win the red ribbon. And finally, there are 14 horses that can win the green ribbon. So to figure out what the permutation is, or how many different ways the horses could win the ribbons, we would take 16 for the blue ribbons times 15 for the red ribbons times 14 for the green ribbons. When we do that multiplication, you can do it on your calculator very quickly. We get 3,360. So there are 3,360 different ways the horses could win blue, red, and green ribbons. Now we're going to find the number of permutations of the letters H, A, N, D, L, and E. That would be a 6 factorial. So 6 times 5 times 4 times 3 times 2 times 1. Go ahead and do the math for that. You can use a calculator. The correct answer is 720. Now we're going to write the number of permutations for the letters G, R, A, V, I, E, and S in factorial form, and then we'll multiply. There are 7 letters, so it would be a 7 factorial. So 7 times 6 times 5 times 4 times 3 times 1. I think I forgot to say times 2. Sorry about that. Go ahead and write that down and figure it out mathematically. Pause the video Once you've done it, then you can check your answer. The correct answer is 5,040. Pause the video at this time if you need to copy down anything that's still on the screen. Now for example 3. Women's Olympic ice hockey tournaments have 8 teams. Find the number of different ways that teams can win the gold, silver, and bronze medals. Well, we have 8 teams that can win the gold. Once a team wins the gold, then there would only be 7 teams left for the silver, and finally 6 teams left for the bronze. So we would have 8 times 7 times 6. Go ahead and copy that down. Find your answer. Pause the video until you do have an answer. The correct answer is 336. There are 336 different ways the teams could win gold, silver, and bronze. Now for part B, it's actually referring to the example we did previously on the page, for example 3 above. The number is not found by finding 16 factorial. That means for the horse show. We didn't take 16 times 15 times 14 times 13 times 12 times 11 times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We didn't do that. Why didn't we do that? We need to think about that. Well, the reason why we didn't do the factorial of 16 is because not all 16 horses are going to get ribbons. Only 3 ribbons are awarded. So we can only use the first 3 factors in the factorial to find the number of possible outcomes. That's why we only did 16 times 15 times 14. Pause the video to get all of this explanation written down. Then we're going to do another example. We're going to find the different ways I can pick class officers of president, vice president, secretary, and treasurer in a class of 25 students. Well, for president, we would have 25 students available to be president. Then, for vice president, there would only be 24. For secretary, there would be 23. And for treasurer, 22. So we end up with a math problem of 25 times 24 times 23 times 22. Pause the video to find how many different ways I can pick class officers. The correct solution is 303,600 different possible combinations. If you want to do some online practice, you can go to phschool.com and do the online quiz with a web code of ARA1205. Also look for an activity lab. Hopefully I'll have it loaded on here so that you can complete the activity lab also for extra credit. See you in class tomorrow.